Hello, welcome back. All right, we're going to look at the different types of protein. So the three types we need to be aware of are globular, and then conjugated, which is basically a globular protein with one extra thing we have to be aware of. And then something completely different are the fibrous proteins. So let's start with globular. So they tend to be spherical and water soluble. And the reason why they're water soluble is, if you remember, proteins are made from amino acids. The amino acids whose R groups are hydrophilic tend to be on the outside. So hydrophilic R groups on outer part of protein. So it's able to interact with the water. The different types of globular, you can have hormones and you can have enzymes. Insulin is a hormone, and in order for it to be able to do its job, it has to be able to travel in the blood. So the only reason why it can travel in the blood is because it's water soluble. And why is it water soluble? Because some of the amino acids that make up the structure, the R groups with the hydrophilic region, they are found on the outer part of this spherical protein. Okay, conjugated is basically globular, but it's got one extra thing to be aware of. It's got this thing called a prosthetic group, which is it's non-protein part or non-protein structure that's been combined with the globular protein. So it could be a lipid, and if you combine a lipid with a globular protein, that gives you a conjugated protein, and that would be called a lipoprotein. If it was a carbohydrate, it would be a glycoprotein. And you get these on like cell membranes. As you learn more about cell membranes, that'll become a bit more obvious. And then you can have something that's completely different. It's metal ions. So a good example would be the iron ion, Fe2+, and that is found. The most obvious one is hemoglobin. Hemoglobin wouldn't be as effective at carrying oxygen if the iron ions or the prosthetic groups were not connected to this protein. And catalase as well. It's also got iron ions as well, but its job isn't to carry oxygen. Its job is to speed up the breakdown of something called hydrogen peroxide, which is H2O2, which your liver is producing, and it's something that's not it could kill us. So we have to be able to break it down really quickly. So there's our conjugated proteins, hemoglobin and catalase, and our globular would be our enzymes and hormones, and one example of a hormone would be insulin. Now, something completely different is fibrous. So what makes them different is they are insoluble. They do not interact with water. They are very strong and long, and the way they're made is usually by a very small number of amino acids repeating themselves. There's some fibrous proteins which may only be two amino acids that are repeating themselves over and over again to make this really consistent long structure. And the amino acids that make up these fibrous proteins, they tend to have very small R groups, something like cysteine. If I'm spelling it right now, that's got a small R group, and that's something that's found in collagen. Okay, so the three types of fibrous protein, so all these insoluble structures, are keratin. This is what you tend to find in your hair and nails. Very strong, and it's very inflexible. And what makes it really inflexible is, let's just add actually, it's inflexible it's because of the disulfide bonds. So cysteine has got sulfur in its R group, so that would you'd find cysteine in keratin as well. Elastin, another fibrous protein. This is what lines the blood vessels. And collagen, this is your connective tissue. So examples are tendon, cartilage, bone. Well, we'll go over tendon, cartilage. I'll do. So that's it. Next video, we're going to go into a bit more detail about collagen. All right, see you later.